You've watched it 100 times. Goku plants his feet. He cups his hands at his side. A blue sphere of light gathers between his palms, crackling, growing, humming with power. Then he thrusts forward and unleashes a beam that levels mountains. You've probably even done the pose yourself as a kid, shouting the words in your living room. It looks unstoppable. It looks like the ultimate expression of strength. But if you actually ran the numbers on what's happening to his body in that moment, the real answer is far stranger and far more brutal than anything the show ever depicted. Because the truth is, Goku wouldn't just win the fight. He'd kill himself first. Let's start with what a Kamehameha actually claims to be. In the show, it's described as concentrated life energy, condensed into a beam and fired outward. Setting aside the fictional Kai for a second, ask yourself a basic physics question. Where does that energy actually come from? Every real energy release you've ever seen, an explosion, a rocket launch, a lightning bolt, obeys one unbreakable law. Energy cannot be created. It can only be converted from one form into another. This is the first law of thermodynamics, and it applies to fictional energy blasts exactly as ruthlessly as it applies to a car engine. So if Goku is firing a beam capable of destroying a mountain, that energy has to be converted from somewhere inside his own body. And that's where things get gruesome. A team led by physicist Rhett Allen, who has spent years publicly breaking down the physics of comic book and anime powers, has pointed out that scaling a human-sized energy blast up to mountain-leveling force requires output in the range of multiple megatons of TNT equivalent. For comparison, the atomic bomb dropped on Hiroshima released roughly 15 kilotons. Goku's attacks, even conservatively estimated from on-screen destruction, blow past that by orders of magnitude. Now here's the question that actually matters. What happens to a biological body that suddenly converts that much of its own mass or stored energy into an outward blast? The honest answer is nothing survives that. Human biochemistry runs almost entirely on ATP, adenosine triphosphate, the tiny molecular battery your cells use for literally every function you perform, including thinking about this sentence right now. Your entire body, at rest, produces roughly 100 watts of power. A trained athlete in an explosive, all-out effort like an Olympic sprinter might briefly spike to around 2,000 watts for a few seconds before their muscles are physically overwhelmed by the metabolic byproducts of that effort. A single Kamehameha, scaled to what you see on screen, would require output roughly 1 trillion times greater than that, occurring in a span of seconds, sourced from inside a body built out of the same carbon, water, and protein as yours. There is no metabolic pathway on Earth that does that without catastrophic failure. Bioenergetics researcher Herman Poncer, whose work at Duke University focuses on how the human body allocates and burns energy, has shown that even our most extreme athletic outputs are tightly capped by mitochondrial efficiency, the literal chemical machinery inside your cells that converts fuel into usable energy. Push past those limits and you don't get more power. You get cellular damage, overheating, protein breakdown, organ failure. So picture it happening to Goku in real time. The moment his body attempts to generate anywhere close to that output, the heat alone would cook him from the inside out before the beam even left his hands. Think about what your body does when you have a fever of just 104 degrees Fahrenheit. You feel like you're dying because you nearly are. Proteins in your body begin to denature, meaning they physically lose the shape they need to function, somewhere around 106 to 108 degrees. Now imagine a process attempting to release megaton-scale energy through human tissue. The localized heating wouldn't raise his temperature by a few degrees. It would vaporize the water inside his own cells almost instantly. You've felt steam burn your hand from a kettle. That's water converting from liquid to gas at 212 degrees. A tiny, controlled amount of energy. Now scale that reaction up to the level required for a Kamehameha, happening inside every cell in his arms and torso simultaneously. There isn't a version of that which leaves a body intact enough to stand back up and keep fighting. But maybe you're thinking, isn't this the whole point of Kai? That it lets him break the normal rules? That's a fair pushback. And it's worth taking seriously, because it's actually the more interesting question buried inside all of this. The show gets around the energy problem by inventing a fictional resource, Ki, that supposedly doesn't obey conventional biology. But even fictional resources have to obey internal consistency, or the tension of the story collapses. And the show itself acknowledges the cost. Characters are shown physically exhausted after large blasts. Some techniques, like the spirit bomb, are explicitly framed as borrowing energy the user doesn't naturally have. Even within its own fictional logic, the show is quietly telling you that this amount of energy isn't supposed to come from a human body for free. Which brings you to the real reason this trope works so well on screen, and the real reason it would never work in reality. Fiction lets you separate energy output from cost. In the real world, those two things are always permanently linked. A study on extreme human exertion, published through work by exercise physiologists studying ultramarathon runners and elite strength athletes, found that even world-class performers hit hard physiological ceilings, not because of willpower, but because muscle tissue, ATP regeneration, and heat dissipation all have upper limits that cannot be trained away. Push a real human body 10% past its output ceiling, and you get torn muscle fibers and heat exhaustion. Push it 1 trillion times past the ceiling, and there is no recognizable version of surviving that left to talk about. So why does watching it feel so satisfying anyway, even knowing all of this? Because your brain isn't actually evaluating the scene for thermodynamic accuracy. It's responding to something much older and much simpler. Humans are wired to find displays of overwhelming, decisive power deeply satisfying, a psychological pattern some researchers connect to our evolutionary history of assessing dominance and threat in social hierarchies. When you watch Goku charge that attack, you're not doing physics in your head. You're pattern matching to an ancient primal sense of, this individual could destroy anything in their path. And that sensation feels good regardless of whether the energy math checks out. Which is exactly why no one in the theater is thinking about ATP synthesis while the beam is charging. But now you know what's actually being hand-waved away every time that pose happens on screen. Not just a made-up energy source, but the single most fundamental rule matter and energy obey in this universe. Real power always has a cost. Muscles fatigue, cells overheat. Bodies break down long before they generate even a fraction of what a Kamehameha would require. So the next time you see that blue light gathering between two cupped palms, you'll notice something different than you used to. Not raw power, not invincibility. You'll notice the quiet biological bill that would come due the instant that attack was actually real. A bill written in burst proteins and boiled cells that no amount of training could ever pay. You've watched it 100 times. Now you know what you were actually watching. Not the birth of unstoppable power. The one attack that would have ended him before it ever left his hands.